7.3 and 7.4 deal with rotations and translations. Now rotations, again, we're only doing the basic ones here in this class. So we will get to that. I'll have a different recording to show you how to do that by hand. Your warm-up today, talking about isometry. Isometry of a transformation preserves A, length and distance between 2 points, B, angle measures in parallel lines, C, all the above, or D, none of the above. And if you recall, you need to know that definition for your test. It is all of those. Length and distance between the points, and angle measurements and parallel lines all have to be the same. They cannot change. All right, for 7.3 and 7.4, we're dealing with rotations and translations. And rotation is to turn the figure. And center rotation means to return it, the fixed point where the figure is being rotated. So, for example, if I have a point out to the side of my figure and I'm rotating about that point, that's my center rotation. Or if it's the origin of the coordinate plane, that's my center rotation. Angle of rotation is the angle through which the preimage is rotated to form the image. And for example, they say rotate it clockwise 90 degrees. Well, 90 degrees is the angle of rotation. And of course, rotational symmetry occurs when a figure can be rotated less than 360 degrees about a point so that the image or preimage looks the same. For example, if I have a square, and let's draw out a real square. Okay, so I have a real square here. And if I rotated that, A, B, C, D, and I rotated it 90 degrees. Okay, I get the same exact figure now. I did it by hand here. A, B, C, D prime. Okay, it's rotated, but it looks exactly the same. And I can keep doing that as long as it's less than 360 degrees. If you have to rotate it 360 degrees, you didn't change anything. Right? But you have to rotate it less than 360 degrees, but it would still be, if the line on top of each other with different points in that location, then it has rotational symmetry. If a figure is rotated 90 degrees counterclockwise, here's a quick hint. You can switch the x and y values, then change the signs to be a positive and a negative. All right? For example, you have x, y. You rotate it 90 degrees counterclockwise. You change the signs of those numbers. And I'll give you a real location. If I rotate it 90 degrees counterclockwise to point A, and it was originally, the pre-image was -1, 2, then the image, A prime, would become the opposite of 2, which is -2, and the opposite of -1, which is +1. All right, if you rotated 180 degrees, all you have to do is multiply by -1. So you change the signs of your original problem. Again, if A was located at -1, 2, your image, A prime, would be located at, change the sign, +1, change the sign, -2. Here's how you would do it, a rotation, counterclockwise or clockwise, if you had to do it by hand. You want to use a thin sheet of paper. So you get a thin sheet of paper, something you can see through. We call trace paper, patty paper, or any thin sheet of paper that you can see. You want to draw a line from the figure to the fixed point, okay, the point that you're being rotated about. And you want to redraw the sheet of, figure on that thin sheet of paper and label the points. Then you want to use a protractor to mark the angle of rotation, and I'll show you how to do that by hand on another video. And then you want to line the center of the protractor with the point of rotation at the bottom of the protractor in the line. Mark your angle on that paper, not the thin sheet. Okay? You're going to rotate that thin sheet so the line that you drew lines up with the marks that you made. And then you can see where your figure would be located on your paper, and you'll mark those points, redraw it, and label it correctly with the prime marks. And again, I will show you in another video how to do that. Translation is a figure that is moved from one position to another without turning. That means you slide the figure left, right, up, down. So coordinate notation, you'll have to know how to do this. X, Y, yields or maps, x plus 6, y minus 2. So you just take the x value and you add 6 to it. You take the y value and you subtract 2 from it. Okay? For the vector 6, negative 2. Anytime you hear the word vector, that means you're doing a translation. Amount those points. So if it's positive, you're going to move it either for the x, you're going to move it to the right. If it's positive for the y, you're going to move it up. All right? If it's negative, you do the opposite. Vector notation would just be, and you see it written with the little, that's more parentheses, but little bits of those little arrows. And more looks like that, which is harder to do on the computer. Vector is a quantity that has both direction and magnitude, and it represents by an arrow drawn between the 2 points. Your initial point, the beginning point of the vector, and your terminal point, the ending point of the vector. So you may have something drawn out like A and then a point over here, B, and an arrow drawn between those two. A is your starting point, your initial point. B is your ending point. Okay? That's your terminal point. So you have to look at your picture to know where you start from and where you end from. Component form is the form of a vector that combines the horizontal and vertical components of the vector. All right, we're going to go back to this. I'm going to show you in a different video how to do these next two with rotations. This one here is a translation. And so I want to go ahead and do this one in the video. We have L, M, N. L is located at 0, 3. 0 places on your X, up 3 on your Y. M is 4, 2, 4 places on your X, 2 on your Y. N is located at negative 3, negative 1. And I connect those 3 points because it's a triangle. And then we're going to find the coordinates of its vertices if it's translated 5, 0. And remember, kind of got these little groupie marks. 5, 0. That means I'm going to move my X values 5 places to the right, but I'm not going to do anything to my Y values. So my new location, and if I can do it either by graph or, it's given me, if I was in an L, my X values moved 5 places, and my Y values moved 0. So what does it give me? L prime is going to be located at 5, 3. So L, 1, 2, 3, 4, 5, 3. Okay, make sure I got a little prime mark there. And M, I'm going to do the same thing, but I'm just going to use the point. From M, I'm going to move 5 places to the right. 1, 2, 3, 4, 5. M's right here. I move 0 on my Y. Okay, and I could do, again, by hand on my N. My N was located at negative 3, negative 1. So I'm moving it 5 places on the X value. No places on the Y value. That's a 0. There's a black Chevy. Okay, so once I get that, my N prime is going to be positive 2, negative 1. Notice the exact same picture, just moved to the right. Now, please open the video dealing with rotations to follow how to do it by hand.